The default Azure Credential class is part of the Azure SDK for .NET, and it is specifically designed to simplify authentication to Azure services. It does that by adapting to different environments without requiring code changes. So, when an application needs a token to access something, default Azure Credential will try to use my own local developer credentials when developing locally. When deployed to Azure, it will default to a managed identity. And when deployed on-premise, it will try and use an app service principal. We don't have that last scenario, but we do have the first two. So let's see how this works. What we want to do is use my local credentials, and by that I mean the credentials with which I'm signed into Visual Studio. So use that when working locally, and use the managed identity when we're on Azure. One thing to do here is to check whether the correct account is associated with Azure Service Authentication. To do that, go to Tools and then Options, and then search for Azure Service Authentication. There we go. Now you can open the account selection and make sure you have selected the correct account here. So that should probably be the one you use to sign into the portal. That is what I mean with local credentials, i.e. the ones associated with my local Visual Studio. Alright, that seems to be okay. With that out of the way, we can already start using default Azure Credential. We don't need a new package for that. The class is contained within Azure.Identity, and that was installed by default when we installed one of the storage packages. So, let's new one up. There we go. And then we need to use this default Azure Credential to get a token that allows accessing the SQL Server database. We do that by calling getToken on it. And we store the response in a variable, accessTokenResponse. Credential.getToken requires us to pass through a token request context. So let's do that. And that requires us to pass through a set of scopes. Scope in this context can be seen as the level of access that needs to be granted. It is this scope that is part of the verification of the token at level of the thing you want to access, so at level of the Azure database. The default scope used by Azure is https database.windows.net -.default. It's part of an array, so let's make sure I use the correct syntax here. Then we need to add that when building the connection string object, the SQL connection in this case. So let's build such an object. That's defined in Microsoft.data.sql client. I get the connection string. We still need that. The connection string I'm looking for is the one with key travel inspiration DB connection. So that's likewise code as I had here. And on it, I need to set the access token. That needs to be set to the value from the access token response. And then I need to pass through that SQL connection object when calling into use SQL Server. Alright, that should do it. What will happen now is that getToken call will get a token to access the database with my local identity, so the identity I'm signed in with to Visual Studio when running locally, and it will use the managed identity to get that token when deployed. Important that before doing this is that we change the connection string again. So, what is important here is that we remove the authentication part here. The authentication now happens with that token, and it's that token that is fetched via my local identity and or the managed identity. So the authentication part differs, and that's why it shouldn't be in the connection string anymore. Alright, let's try this locally. Let's send a request to get the itineraries again. And there we go. That works again. Now let's publish this. Publication was successful, but this won't work yet, as you can gather from the fact that the service is unavailable at the moment. That's because that remotely, we still have that authentication part in our connection string that needs to be removed. So let me open the environment variables. Let's go to connection strings, as this is the one that's being used. And let's have a look. So we remove the last part here. Let's click apply. Let's click apply again. Our app service is being restarted. Now let's see what gives if we try and get the itineraries. And there we go. This works again. So this is how you can work with the default Azure credential to easily enable local development without having to change your code before you deploy and without having to worry about accidentally synchronizing or inputting the wrong connection string. The connection strings are now the same locally and on Azure. Important to know is that this default Azure credential thing is not something only related to Azure SQL. You can also use this class to get tokens to connect to Azure Storage and or to a lot of other Azure services. So it's really something very common to use when developing on Azure. Time for the section summary. This section was about working with Azure SQL. Azure SQL is a cloud-based database service offering by Microsoft, offering various deployment options. Options include using a virtual machine with SQL Server, a SQL Server managed instance, and the SQL database option, which abstracts away both the operating system and the SQL Server instance. That's the one we used, as it's the most common Azure PaaS option. You can create an Azure SQL database and server through the Azure portal, with options to configure resource groups, authentication methods, compute and service tiers, and backup storage redundancy. But of course, this can also be done with the Azure CLI. Connections can be made from local development environments using tools like SQL Server Object Explorer, SQL Server Management Studio, and Azure Data Studio. Important for local development is to remember that you need to allow connections from your IP address. Connection strings are used to authenticate and connect to the database, with commonly used options for SQL authentication and Microsoft Entra ID authentication available. Integration with an Azure SQL database from an app is not much different from how you'd integrate with a local database. These days, typically that means via Entity Framework Core in the .NET world. Interesting to know is that there's a built-in policy for connection resilience and retry logic catered to Azure that you can enable as SQL Server option when setting up your Entity Framework Core context. When you deploy an API with an Azure SQL database, this involves configuring dependencies, ensuring network settings and so on, just like with Azure Storage. Here too, the Azure Service Connector resource is very helpful. At the end of this section, we looked into a more secure option for integrating with a database than regular SQL or Entra ID authentication: managed identities. These can be used for more secure authentication, eliminating the need to store secrets in code or config files. And that's a good thing. In essence, managed identities are service principals managed by Microsoft Entra ID, providing token-based security without the need for secrets. But they are an Azure-only thing. That can make local development a bit more difficult. Luckily, the default Azure credential class can be used to simplify authentication, adapting to different environments without requiring code changes. Out of the box, this class will use the credentials you use to sign into Visual Studio when developing locally, and it will use managed identities when deployed to Azure. Important here is that the default Azure credential class is not an Azure SQL only thing. You can also use this class to connect to Azure Storage and or from a lot of other Azure services. We've got an API hosted on an app service. It connects to different Azure Storage services and to a SQL Azure database. But we're still missing a few things. When developing an app, it's important to be able to debug it. Often debugging on your local machine is sufficient to figure out what's causing a bug, but sometimes your codebase may run without issue locally, yet fail when deployed. I'm sure this will sound familiar. In those cases, remote debugging can be helpful. That's what we'll look into first. Another common way to figure out if something's going on with your app is logging. We will learn how to ensure that your logs show up on Azure and how to inspect those logs. Lastly, we'll take it up a notch by learning how to work with App Insights or Application Insights, which is a feature of Azure Monitor that helps with monitoring your app and gaining insights into the behavior, performance, and availability of it. Remote debugging allows you to attach the Visual Studio Debugger to running instances of our API, in this case, deployed to Azure. That means you can inspect your code base while running, including breakpoints and variables, and so on, as if you're in a local debugging session. This is obviously very convenient when you're trying to figure out something that's going wrong, deployed, but works when running locally. You don't get this capability by default though. You need to enable it. We're looking at our app service over on the portal. Let's navigate to the configuration blade. If we scroll down here on the General Settings tab, we can find a configuration section that allows us to enable remote debugging. We also need to pass through the Visual Studio version we're using. That's 2022. Let's save this. Alright, that should do it as far as configuration of the app service is concerned. But we still need to do something else. The last thing we published was, as is a good practice, a release build. But obviously debugging doesn't work on a release build. We need a debug build for that. So let's switch to Visual Studio and let's change the configuration setting of our publish settings here. It's currently set to release. And I want to set that to debug. Alright, let's save this and let's publish. It's publishing in the background. There's one more thing we need to do before we can effectively start to debug. Let's open the debug options from Visual Studio. And here we want to make sure that enable just my code is unchecked. This allows Visual Studio to debug the optimized code that was deployed to Azure by using the included symbol files from our local bin folder. Now let's click OK. In the meanwhile, publication has succeeded. So now we can attach a debugger to our app service. In the menu on top here, choose Debug and then Attach to Process. We want to set the connection type to Microsoft Azure App Services here. And then click Find. We can find our travel inspiration web app service. Let's click OK. It's connecting to the remote debugger. And this is a list of processes running on our app service that we can attach a debugger to. W3WP, that's the default IIS worker process. That's the one we want to attach the debugger to. So let's select it and click Attach. Alright, there we go. We are now debugging remotely. As an example, just to check whether this effectively works, let's say we're gonna set a breakpoint when searching for destinations. So let me just add a breakpoint here in the handle method. And then let's send a request over on Azure to search for destinations. So let me just switch to the portal. This is definitely our app service running online. And let's send a request to API/destinations. And we hit our breakpoint just as it would if we were running locally. This time, however, the code is running on our app service. So that's how you enable remote debugging. Next to debugging, logging is also essential to figure out issues. Let's look into that next.